From now on, I'm going to talk about what I learned this week. If you hang a negative bias on a MOS, the hole is stacked. So there is no depletion area, but there is a COX. Because MMOS is a p substrate, group 3 elements must lose a hole and negative space charge must be formed in order to make the depletion. A small increases in the gate voltage results in a small area of depletion. Since they are serial connections, perform parallel calculation. As the voltage increases on the CD, the depletion width increases. Finally, CD is getting smaller. Then if the pi f becomes 2 pi b, depletion region becomes maximum. When the depletion region becomes maximum, the total cap becomes minimum. On the graph, it is divided into two categories in the strong inversion area. This is the frequency difference of the detector. When the upper part is measured by low frequency and the lower part is measured by high frequency, the rate of formation and recombination of the minority carrier of the inversion is not observed in high frequency. That is, the frequency is much faster than the generation and recombination speed. When it is low frequency, it is difficult to detect depletion region by generation and recombination of the inversion layer. Now next to principle of MOSFET. If you look at the structure of the MOSFET, the metal is called the gate, and the areas on both sides of the gate are called the source and drain, respectively, after doping them in N-type semiconductor. The wall source is used to supply electrons and drain is a place to flow electrons. If no voltage is supplied to the gate, no channel is formed and no current is allowed to flow. If a positive voltage is applied to the gate, the negative charge will build up in the semiconductor area as long as the length of the gate according to the cap principle. A negative charge builds up on the top of the semiconductor and changes the top of the semiconductor to N-type when the voltage is increased. An N-type channel is formed between the source and drain and is capable of passing through the current. It is the basic principle of the conversion to control the current between source and drain by the voltage at the gate. Thank you for listening.